Hello, we are back and just going to do a little bit of introduction this week about what is research? Why are we doing this? Why is it important? Why should you be doing it? So big picture, this is what we're going to cover. What's research? What's the scientific method? Why should research be rooted in testable theory? What are some general approaches to research? What are common forms of research in the learning technologies field? So, starting out, what is research? It is organized, it's systematic, usually involves some sort of direct observation. That's what makes it empirical. Empirical means observable. Often we'll have hypotheses that we're testing, educated guesses based on past experience, past data, that we want to see if I do A, then B will occur. Sometimes we just want to understand what is happening in a current situation. We want to describe the who, what, when, where, why, and how of something that's going well so that we can replicate it, something that's going poorly so that we can improve it. So in our field, with educational research, learning technologies is a subset of education. Education is a subset of psychology. Psychology is a subset of philosophy. Our goal as people who have PhDs, doctorates in philosophy, or who are getting them, like yourselves, we are primarily trying to describe the world, break it down, and understand it so that we can make predictions. Psychology and education try to make predictions about how we can design curriculum, how we can design experience, how we can manipulate variables in order to get people to learn better. And with learning technologies, our goal is to help people learn better with technology. So we have to know a lot. We have to define a lot. Philosophy's main job is definition. And definition comes through observation and testing. So defining research briefly, so it's a systematic process that allows collection and analysis of data to increase general understanding of the world and of a particular phenomenon of interest. We're not just trying to describe things super broadly. We have to narrow down our topic and our focus. So I've got a little image here. So research is going to start with laying out a systematic process. We have to know what methods we're going to use so that we can come to understanding of a problem, a topic, or a phenomenon. From there, we need to be able to analyze. So we have to observe, whether that be collected through a survey, questionnaire, direct observation and field notes, video, audio, interview, focus groups. There's lots of different ways we can collect this, but we have to have a means of analyzing our data. Now, this first one should say data collection, not data analysis. I'll fix that for the future. But in the meantime, we're just going to move on. Second part is data analysis. So we have to be able to analyze. We have to know what calculations are going to be appropriate. We have to set things the right way. We have to have the right Pearson setting. Are we going to do to 0.05, 0.1? Are we going to have a fixed set of coding, an EDIC code set where we're exploring data and people's utterances for particular things that they're talking about to us so that we can understand and look for patterns in it so that we can grow knowledge, develop theory, determine if something worked. So there's a lot of different ways that we can analyze data, but they have to be aligned to what we are trying to understand. And then we have to increase our understanding of that particular phenomenon. So once we're confident in our solution, we may have to come up with a business model. We may need to develop some sort of educational solution. Whatever it is, if we have to improve leadership, if we have to change who is in our system to improve the human resource outcomes, if we have to change the tool that we're using in a classroom, that's a decision that the organization needs to make. And so some of this data that we use can help us make better decisions. Some of it helps us just understand what's going on, because a lot of the time we come into situations where something really bad is happening. We don't even know why. But our data can help us get a better picture of what's happening so that we can try to improve the situation going forward. And then finally, we need to understand how we can increase what the rest of the world understands. So we have to disseminate this out through articles, through presentations, through videos like this one, so that other people can learn from what we think we now understand, while always recognizing that knowledge is constantly changing. It is malleable, and we have to be prepared for the fact that just because we think we understand something one way today doesn't mean that it will always be true. And then finally, we may need to continue the data collection with new data. We may have new questions that come out of what we collected the last time, or there may be different aspects that we want to understand more about that we have to explore, and that's the next study. Or sometimes our hypothesis was incorrect and we need to generate new hypotheses and test again. So there's a lot of different things that go on in our research process, but it is effectively a cyclical or circular process, despite the fact that this is a very odd looking little process here. It's what is common. You're not done just because you finished one study. There are many more studies that have to come afterwards. And sometimes you may finish your study, find out you were wrong, and you didn't get a whole lot out of it, so you've got to try again. And again, research is usually cyclical. One study isn't always enough. You're going to have to repeat to see if it happens more than once. Most of our research is done in classrooms or training, and you have a different group each time. Just because it worked once doesn't mean it's replicable. It doesn't mean that it's going to happen ever again. So we're going to have to keep studying this, because most of what we do is incredibly complex and it involves humans who cannot be relied on to be consistent. So we're going to have to be really careful about what we do with our studies and what we make claims about. The basic purposes of research. First is to explore what exists, what's out there. I have to then describe, what do I see? What can I observe? What are teachers doing with technology? What are trainers doing with technology that is good or bad or otherwise? What's happening? And then we have to explain. So why is it this way? Is it this way because of path dependency? It's the way we've always done things, so we just keep doing it even though it doesn't work? Or is it happening because we don't have enough resources? We need to allocate more resources, or we don't have enough training. We have to explain what's happening. It's not enough to just know that it exists. We have to be able to try to make improvement. So why do we conduct research more broadly? Performance improvement is a big thing. We want to improve how people perform their jobs. We want to improve how training is conducted. We need to improve how instruction is delivered, how people learn. We may have a technology product that we're using to help people learn, and we want to improve it. We want to improve its usability. We want to improve its efficacy. Sometimes we just want to test theory. We have a theory that things work in a particular way. People learn in a particular way with technology, and we need to be able to test that extensively. And sometimes we just need basic descriptive research to understand what situation is happening, what phenomenon is occurring, and what we think it means. And that's a really important part of research, and we don't really do enough of it anymore. We make too many assumptions a good deal of the time that we think we know, and we usually don't. As I said, research is iterative, but it's not just iterative within your own research, it's iterative based on other people's research. So you have to ground your theory in what other folks have already done. The knowledge that has come before us is not useless. Just because an article is from 2013 or 2002 or 1968 does not mean that it's not relevant to what you're doing today. Your work today is an outcome of study after study after study, piece after piece after piece over all that time. So you need to understand it and be able to root your research in that. Because understanding it requires many different perspectives, and it's going to be really difficult if you think your perspective is the only one that matters. Sometimes we're asking what questions. So, what are the facts of what's happening? What were the outcomes of what we did? And sometimes we have how questions about the process, what happened during the process. And that process may have resulted in explaining why something went well or something went poorly, because maybe somebody tweaked something that we didn't predict, that we didn't detail, and we need to better understand it. So, process and outcomes are two of the major things that we do in this iterative process. But a lot of the time, we're going back and forth between the two. We can't just focus on outcomes. We also need to go back and forth between process and outcome. Now, we can also do either formal or informal research, and this is a choice that we have to make. So, if you're doing formal research, it's going to require quite a bit of forethought. You're going to have to do a lot of planning ahead of time, and that's the kind of research that you will be expected to do in this program. That is what doctoral research commonly is. You can't just go out and collect data. You have to have institutional review board approval. You have to have supervisor with city certification and faculty status at the university to go do data collection, either formal or informal. Now, sometimes opportunities will arise in a classroom to collect data, and sometimes we collect just informal data without knowing that we're doing it. Teachers have lesson plans, they may have logs of student use of different products, days when it didn't go well, things like that. And we can go back and do a retrospective analysis, but you still have to have permission from the university to conduct that study. That would be more informal. And sometimes during formal research, we may do informal research, but you have to have permission for that too. So in my first dissertation, we were doing direct observation in the classroom where they were using the computer game that I made. And we had a set of formal semi-structured interview questions they were supposed to do after the end of the study was done in terms of the student use of the game. But we also did informal interviews where, as we saw things happening with the students or with the teachers that we needed to understand more, we would ask informal questions as they arose. Those weren't designed ahead of time, and they came as a result of our interactions with them. So that's more what we do when we do informal. Now, if we're going to change practice in a classroom, it shouldn't just be because I feel like it. It should usually happen because it's got some empirical support. We've got observed data that comes from a formal research process that says if we do this differently in this particular way, based on the numbers or based on the description, based on the interviews, then we should make this change, but we still have to test it. We still have to do further research to see if it worked. So again, there's going to be a lot of observations. This is not a simple, easy process. All of our research is based generally in the scientific method, more on the quantitative side, the numbers side, than the qualitative side. However, we still try to root everything in a formal process. With the scientific method, we know that knowledge is always changing. So we always have to test what we think we understand. Just because we understand it today does not mean that it is always going to be correct. Knowledge needs to be empirically verifiable. We have to be able to make observations. Just saying something is true doesn't make it true. So we have to be able to design experiments. We have to be able to conduct formal protocol-based observations, interviews, in order to determine that knowledge is, in fact, supported by evidence. And research should always be conducted in an ethical fashion. I sit on the Institutional Review Board currently at UNT, and sometimes people want to do things where we have to make sure that no potential harm can happen because they're doing things that are necessary but could be a little scary, especially when you get into things like cyberbullying, which I had a doc student do a dissertation on years ago. We just have to make sure we're protecting our participants, and we call them participants, not subjects. The other thing that we always want to do is be transparent about our research with scientific methods. So new knowledge should always be shared publicly as much as we possibly can. You still have to get through peer review process, which can be hard, but the only way for the field to grow its knowledge is for us to all be sharing with one another. Now, there are two basic research forms. The first is basic research. That usually is kind of fundamental research that takes place in laboratories that we're kind of familiar with. It's usually just trying to explore what exists. Applied research is really primarily what we do in the learning technologies field. Really in the social sciences, we do primarily applied research. I do the same thing in the business field. Most sociologists do applied. We often do evaluation, action research. We look for social impacts, and everything's happening in naturalistic settings, which means people are doing their jobs live. And so we can't predict what's going to happen, which makes doing experimental research that is necessary for basic incredibly hard, if not impossible. So basic research, that's usually kind of foundational. That's when you're trying to understand molecules a lot of the time in hard sciences, physics, biology, those kinds of areas. That's why we don't really do a lot of it in our field. It's focused on generalizability, where things are going to happen over and over and over again the same way, usually in clinical settings. Sometimes when we do it in our field, which is infrequent, we'll use cognitive science or neuroscience as a basis. So that we can do lots and lots of repeat trials to make sure that we're seeing the same thing over and over again. But because of lack of opportunities and incredible expense to do basic research, we don't do it very much. And basic research usually isn't for commercial gain, and right now it's hard to get funding for anything that's not being partly funded by people who are trying to make money. So applied research tests, the application of methods, ideas, theories. We're just trying to overcome practical problems in the classroom most of the time, whether that be a corporate training classroom or with online training, whether it's higher ed or K-12. We all have tons of problems that we're trying to overcome. So we're trying to test how we can improve our application of curriculum, our different instructional approaches, our use of technology, whatever processes we've developed. And the basic questions are, is it usable? Does it work? If this kid throws the plane, is it going to fly? It's the same thing for us. If I do this in the classroom, is it going to fly? Is this curriculum going to work? Is this tool I'm trying to implement in this way going to be effective? So again, when we're thinking about applied research, if we're trying to understand, describe, or address practical problems, this is the most common approach in the LT field. We try to use a lot of new technologies. A lot of the time people will try new pedagogies or a whole new curriculum because we've detected a problem. That makes it applied. Somebody is actually trying to apply what you created. So don't call anything that you're doing basic, because that's not what we do. Now from there are three basic general research approaches that we use in our field. The first is what many of you are familiar with, which is quantitative, which in the textbook is going to be referred to primarily as fixed. So we try to use numbers. We try to use data that is in the form of numbers to detect relationships, usually variables. If I do X, then Y happens. And the whole goal is to get objective generalizable knowledge. One of the challenges is that with most of the quantitative research that's done in our field, it's still done in naturalistic settings. and it's not repeated. So we don't know if because we found it one time it'll ever happen again. Um, so that is a challenge. With qualitative research, which is the next one, so, which in the book is primarily called flexible research, trying to get knowledge through analyzing people's words, pictures, objects as a result of their subjective experiences. So a lot of interviews, direct observation in the classroom, artifacts, maybe analyzing people's utterances in social media. And this is, again, subjective, so it has its own challenges and problems, just like quantitative does. Usually, in that it's a lot harder to do the analysis because it takes longer. You have to analyze data sets and have multiple people reviewing what you're finding so that you can come to agreement. So in quantitative, you're usually looking at validation and reliability testing to make sure that the instruments that you're using work. With qualitative, you're having multiple people looking at the same data in order to agree that what you see is really what you see to establish credibility and trustworthiness. And then the last one is called mixed methods, or I prefer multi-strategy, which is how it'll be referred to in the textbook. Mixed methods is frowned upon as a term and as a practice by a lot of people in our field, which is why multi-strategy is better. You're usually using kind of the best possible uses of quantitative and qualitative because you want to understand what knowledge the quantitative can provide. So if I run my t-test, was there a detectable statistically significant difference from time A to time B? If not, I need to know why not. So I'm going to use qualitative methods in order to interview participants, to do a survey, to go back and look at the chat logs, to find out what went wrong so that I can explain this negative phenomenon that was not what I wanted. So you're using one to inform the other. Sometimes you can use qualitative, like grounded theory, in order to develop an understanding that allows you to build comparison and treatment studies, quasi-experimental studies, so that you can test theory that is generated out of your qualitative research using quantitative methods. So it goes the other direction. So there's a lot of ways that we can do this, but most researchers have their own preference, quant or qual, and they're often really loud about it. And you will probably hear some of the faculty here and at conferences and elsewhere in your career be really loud about what they think constitutes research and what does not. I'm going to tell you that they all have benefits and they are all valuable. You just have to choose the right method for what you want to know. And not everything is appropriate to quantitative. Not everything's appropriate to qualitative. Not everything's appropriate to multi-strategy. However, if you choose the right tool for the right task, you're going to be okay. So again, quantitative, they're deductive. You usually try to test a theory or a hypothesis against whatever data that you've collected. If I do this, then this should be the result. This is usually going to result or require a lot of math. And you're trying to find cause and effect relationships most of the time, although in our field, we don't really go beyond correlation in most instances. And correlation is not causation. But what you're saying with the correlation is that it's probable that you will find a positive outcome the next time someone uses the learning technologies tool or training. And one of the things I want you to note is with quantitative in our field, we don't use mathematical models that are using massive data sets. We're not gathering data from 5,000 people out of a possible 10,000 people that are using a product. We are making inferences usually based on small data sets. And so we use inferential statistics. So we are inferring from the sample that we've gotten that if we do the same thing again, that it should have a similar result in the future. That's not always true, but that is the assumption. And it's just something to keep in mind, is that we're not doing statistics on the level of the hard sciences. We're doing it on the level of inference, which is not, we can't trust it as much. And quant research is scientific method basis. We have to reject the null hypothesis. You're going to have to develop instruments that have to be validated with your particular sample and population. Just because somebody else has already validated an instrument doesn't mean it's going to work for you. You have to revalidate it. You usually have experimental control and manipulation of variables, although sometimes it's just comparison and treatment of two similar groups. And then you have to explain how they are similar, which I had to do once upon a time. And again, the data is modeled and it's analyzed based on certain rules, including we can predict X, Y, and Z to the point where you can look in the back of a statistics textbook, and if the t-test is run at this alpha, then this result means X, and you can look up the result of X in the back of the book. With qualitative methods, you can't do that. You're looking at complex phenomena, questions that aren't really well answered, topics that are poorly understood, things that math doesn't really lend itself to, things that are changeable and shiftable, like people's beliefs or their experience may change from day to day over time. They may not understand the meaning of a term the same way. You may have 10 people in a group and all 10 of them understand the meaning of an experience or a tool or a practice in completely different ways, or in just enough different ways that it causes conflict. So qualitative methods helps us get into these questions of who, what, when, why, where, how, and gets into individual experience as well as group experience. We can also, as I said before, generate theory because we're getting into a lot of detail. We're asking questions, we're doing interviews, we are doing direct observation, we're looking for patterns. And based on those patterns, we think we can then predict what will happen in the future, and that's a hypothesis. And then we can test that hypothesis with quantitative. So quantitative and qualitative really go hand in hand in a back and forth relationship that's very positive, if we allow it to be positive. And one of the other criticisms that you will hear from quantitative researchers who don't really understand qualitative is they will say that they are not empirical or they are not rigorous. They are both empirical because they rely on observation, whether that observation comes from a questionnaire or from interviews or from direct observation in the classroom. They are empirical. They're also rigorous because they have a different credibility and trustworthiness process, usually called triangulation, where you may have multiple observers on the same data set, multiple forms of data so that you can confirm that X, Y, and Z is happening the same way. Things like member checks, where you go back and say, this is how I interpreted it. This is what I think you said, participants. Is this what you really said? So it's just different. It's not less rigorous. It is definitely empirical. It's just different. But it still allows us to detect some patterns that we can then test later with quantitative if we see it often enough. And then finally, we've got multi-strategy research. And like I said before, it uses both quant and qualitative methods. And so the quant may be used to figure out if a problem exists. We look at the data and we see that out of 100 participants, 84 failed the test. Okay, we know they failed, but we don't know why. We don't know what was responsible for it. And then we go to the qualitative and we get some description as to what occurred so that we can make improvements. Common research process is going to involve conducting literature review. You got to figure out what your topic is, your question, your problem, phenomenon of study, and it needs to be rooted in the research that has come before you. You can't just make stuff up. Just because you have a hunch, that's not an educated guess. That's not a hypothesis. That's a hunch. It should be rooted in either new data that you've collected or in the data and the findings of people that came before you. So the literature review is the basis of your study. Your hunch is not the basis of your study. You always go back to the literature. We are constantly growing the field based on the work that has come before us. Once we have our problem, our general idea of what we want to study, then we have to choose data collection methods. Are we going to go quant? Are we going to go qualitative? What instruments are we going to use to collect this? Are we going to do direct observation? How are we going to do it? You have to figure that part out next. Then you collect the data. Once you've got your data collected, you've got to organize it, clean it up, get it ready. Then you analyze it. Once your analysis is conducted, then you have to synthesize the data into findings. Sometimes you have to interpret what they mean and explain what they mean. Sometimes they should be self-explanatory. If you ran your ANOVA, your t-test, and you found statistically significant differences, great. But you still have to explain why they're important and what they mean in lay language, in words, not just numbers. And then you've got to report those findings. Could be an article, could be a book, could be a book chapter, could be a presentation at a conference. And then you start over. So in this next section, we're just going to walk through some of the different types of research that are out there. Now, this is not exhaustive, but these are some of them. So one that is commonly used in scholarly practitioner work is action research. You're usually looking at what people are doing right now in their classrooms so that you can try to improve what they're doing. So if somebody's using a tool and they're not doing it effectively, you're using data, observation, interview in order to try to figure out different, better ways to do this, and then continuing to do that observation in there to see if there was improvement. So it's usually cyclical and direct observation within the classroom to see if there is improvement over time based on the actions taken by the instructor to improve the outcomes. Correlational research, we've already talked about a little bit. You're trying to look at the relationships among two or more variables, and you're not looking for direct cause and effect because you can't find direct cause and effect. We don't have a large enough sample size, and our ability to predict is very low in most instances with this type of research. Correlational research is usually math-based, quantitative, whereas action research in the previous one is usually qualitative. We do some action research in LT, but not a lot. That's usually EDD programs, not PhD programs. The one that I was in at University of Houston did action research. PhD programs tend to look more at correlational or other forms of research instead. Cool thing about correlational is it helps you establish relations among variables using math models. Experimental and quasi-experimental are common in LT, and I don't know why it says experimental. Correlational is common in LT, and correlational is, and quasi-experimental sometimes are used interchangeably. Quasi-experimental is usually correlational. Experimental is not common in LT, so ignore that part. It is not. I'm going to say it one more time. We do not do experimental research in LT. It's very hard to do. So with correlational, you are looking often for relationships. So if your big outcome that you're trying to get to is job performance, what are the other variables that are involved? How much does learning new skills improve job performance? How much does motivation improve job performance? How much does motivation improve learning new skills? What are the relationships across these things that lead to increased job performance? Same thing could be said with student performance in class. If you replace job performance with student success, could tie into their learning of new skills in the classroom or learning of content, and that could tie into motivation. There's lots of different ways that you can fit these variables together to try to predict positive outcomes. Historical methods This is one that we don't do a whole lot in our field. Um, Sometimes we'll do it with what's called meta-analysis or bibliometric analysis. I've done this, but it's fairly infrequent, and I did it in business, not in LT. So you're getting whatever data sources you can finally find out there to look at a hypothesis. So for me, my hypothesis was that soft systems methodology, which we'll talk about later in the semester, as a research method in business, should have had a positive, strong impact on the field of academic business research since its inception in, say, 79 to 80. And I had to test that by gathering all the data that I could to see how much it impacted citation counts, how often people were doing that kind of research, whether they were doing it correctly, those kinds of things. And so I use primary and secondary sources. Primary sources are going to be things like articles that have strong evidence. Secondary sources may be references to those in another piece. Uh, Sometimes you're looking at diaries or reports. Some of the things that I had to look at were reports that weren't peer reviewed, so they were of slightly lower quality, but they're still valuable evidence. But again, you're looking at these evidentiary sources in order to try to test the hypothesis. I didn't find super positive outcomes in my study, unfortunately. Uh, Descriptive research. This is something that we use a lot in learning technologies. We're trying to figure out what the current situation is. What's the phenomenon that we're trying to understand? What are the participant views of what's happening right now in the situation? We are describing what's happening, and we're using direct observation, but we're primarily trying to use the views of the people that are experiencing it by giving them questionnaires, doing interviews with them, however we can collect data, but we're trying to describe what's happening right now. Sometimes this can be combined with quantitative. So if a company, for example, is not doing very well and the quantitative data shows that folks are not completing much training, so they're not improving their learning, they're not improving their growth, they're not applying new methods in their corporation, um, then we need to find out why. And then we use descriptive research to do that. Same thing could be happening in schools. Part of the reason that teachers may not be or professors may not be learning new things is they simply don't have time. They're overwhelmed with the amount of work that they already have. And so that could lead to a managerial decision to reduce workload in other areas so they have opportunity to grow through training. Ethnographic research, some people call this case study or field research. That's a little confusing. Case study is an approach that can be done within many methodologies. So don't call this case study research. Ethnographic research can use case studies or field research or a combination, but they are not the same thing. Case study is a data collection, or cases collection is part of methodology, data collection. Field research is a type of research where we go out into the field and collect this. And so in this instance with ethnographic, we often will select cases of individuals, or each person is their own case, or it could be each case is a different department within a company or a different department in a school, or it could be different school districts or each separate cases. And we go out and we conduct field research, maybe through direct observation, like with descriptive, informal interviews, collecting artifacts from what people have done. Again, I mentioned earlier, lesson plans would be one thing, but it could also be student performance on state standardized tests. But it could also be immersive participation. I spent 2 months in a school doing tons of direct observation, participating in daily activities. I actually substitute taught a couple of times during it in order to support this, because I was part of this place so I could better understand it from inside. Next type is developmental or time series, but most people in our field will call it longitudinal studies. you're going to do kind of the same data collection over multiple times over an extended period of time to see if growth or change continues to occur. So just because you found that students learned over the course of the last 2 weeks with your educational game doesn't mean they retained anything 2 weeks from now or 2 months from now or 6 months from now. And it could also be that if it worked this year because you had a lot of training and it supported the students in learning how to use your tool this year, but you drop that training next year, and all of a sudden the next group of students using your game can't use it as well. That's something that you also need to know, and you need to keep going back in and checking to see if the product is working to support learning. Quasi-experimental, we mentioned correlational already. We tried to do experimental design, but this is an instance where we can't do control groups because you can't control all the behaviors. You can't randomly assign people to different groups. There are all sorts of limitations to your ability to do this. So you just intentionally put people into groups, or you take advantage of existing intact groups. So you may be comparing classroom A to classroom B. Classroom A gets the treatment, which is the educational game or the new curriculum. Group B, which has a teacher who teaches similarly, similar kids performing similarly, doesn't get it. And you look to see if there's any improvement between the two. This is how I've done a lot of research. It's very common in learning technologies, especially with tools. And we already talked about experimental a little bit. Again, this is systematic, extremely controlled. You have to have prediction hypotheses. You're looking for cause and effect, random assignment. You're going to have predictor variable, that is the independent variable, which you'll hear about a lot in your career, and the outcome variable, this is what happens, that's called the dependent variable. You control the predictor variable, that's the independent. You do not control the outcome variable. We don't do this much. It's super hard to get the opportunity to do this. You usually need some sort of a lab, and we don't have that. Causal comparative, some people call it ex post facto. You're looking back from what's happened today. So right now, we have a lot of kids failing state standardized tests. Why? We go back and we look at the relationships between the state testing regime, Pearson, the company that produces the state test for us. We look at historical data about how the testing came about, what was the political situation, what was the educational situation, and we try to figure out how we got to where we are. So we don't do a lot of this, but it would be pretty interesting to do some of this kind of research. And then again, correlational perspective, you're trying to make predictions about the future based on observable current relationships. But usually you just have one set of subjects. And then you usually have a couple of variables. So like the job satisfaction one that or job performance one that we had before, if the variables included, say, motivation and job satisfaction related to job performance, we may be able to forecast if they report having high motivation and high job satisfaction, then we should have high job performance. But that's just within one set of subjects. You're not comparing it to another one that doesn't have those characteristics. We also do forecasting. So if we have a set of folks within a group that has a set of characteristics that we detected in our past research, so they have to do X, Y, and Z in a certain order, then we can forecast that they should have to do X, Y, and Z in the same order in the future. Exploratory is probably done more than just about anything else in our field. If I had to guess, don't hold me to this, but I guess that 60 to 70% of our research is exploratory, even if people don't specify that it's exploratory. That's because we do new stuff constantly. We're always using new tools. We're always using new curriculum. There's always some new approach. There's always some new process. There's always some new training. And we don't understand what's going on super well. We're just getting into it for the first time. So we're trying to better understand and define the problem. And we're trying to get into an ability to know how to research it in the future. What methods are going to be appropriate? What participants should we get so that we can better understand what's happening right now, what problem is happening, what phenomenon is occurring. We don't usually use it for decision making, but we can often use it to explore a problem so that we can diagnose what's going on. And then later on, using further data and further research, we can then try to improve decision making. Phenomenological research, this is an inductive approach. Again, it's descriptive like the other type we talked about. It's rooted in a type of philosophy, and you're trying to get into the lived experience, what Habermas calls the Lebenswelt in German. So the life world. So what is an individual's experience? So they may be a single case that we're looking at, or a group of 10 people all in the same place, so we can understand the differences in their experiences as they live through this. There are other forms like interpretive phenomenological analysis that have different requirements. Some of my students have had at least 3 use phenomenology as an approach, and it's pretty effective. It is also very rigorous. So 4 of the general types of research that we do a lot of in learning technologies are needs assessment. What do people need in order to be able to perform better? What are the gaps and problems and other issues? So that's a big reason we use research. And then testing new technologies to make sure that they work. Sometimes we're looking at usability, sometimes we're looking at efficacy, but if a tool doesn't work, we shouldn't use it. So we need to know that. We also evaluate process to make sure that processes are working, that they're efficacious, that people are getting what they need. And sometimes we just look at outcomes. Did it work? Now, you all are going to take a quiz. I want you to retake it until you get at least 90%. I want you to remember stuff that's in this. So if you don't remember, go back and retake it.